Okay, fine. And let's begin. Uh, yeah. So, any questions? Yesterday we did the uh, stream. Fine, introduction to stream was done, right? Before that, some classes were there from Java util package. We saw the comparator. We saw the summary statistics of classes, right? And string joiner. And so, any questions there? And then, of course, we saw the streams. And the stream has a source, and then it has you may use intermediate operations, but ultimately when you use a terminal operation, then it executes the stream. Fine. The intermediate operations used for creating a pipeline. Yeah. So any questions? Yeah. And the exercise if you have done. Yeah. Anyone has any questions? Yeah. Okay. Fine. So then let's proceed, I think. Yeah. Yeah. Okay. So something new for today. And, what I'll do is I'll just pick up one of the code and make some change, and you need to tell me whether it results in a compilation error. Okay. We can pick up any class, which is our class over here. Maybe account class. Let me pick this up and let me make some change in this. It's just some kind of a knowledge sharing which I'm doing. Okay. Something I'm not sure whether you are aware of this or not. Right? I make a change here. This is, this is a keyword, right? Class. Yeah. So I make this change. I save this file. Yeah. So what do you think? Is it going to compile? \u0063 and then LASS. Yeah. Yeah. What do you think? What does it look like? Okay. Should it be getting compiled or it will be giving an error if I try compiling this Java file? Yeah. Yeah. Anyone can answer this? Okay. I'll make a few more changes, and that may be still more surprising to you. Okay. Fine. No, it's a keyword. I'll look at this one. Okay. We have this class account, right? And it implements comparable of account. Okay. ECC \u00AD. I added one character into this, right? Okay. So that, yeah, you can see that's all continuous. Right? I didn't want it to scroll into the second line like that. Yeah. What do you think this will compile? And, do we have a class like this? For it to compile, yeah, this must be some valid class, right? Yeah, anyone? Yeah, what's your answer like? It should compile, it will give an error. Yeah, yeah, you can unmute and answer. Answer. Yeah, someone can give an answer to this. Yeah, at least. Yes or no, something.
No idea, sir.
No idea. Okay, so let's try this thing, right? Let's try compiling. But what's your expectation? Should it getting be compiling compiled or not?
Correct.
Huh? It should be. Sorry, I didn't get that.
Will compile. It will compile.
It will compile. Yeah. Okay. Fine. Let's compile and verify that yes, it gets compiled. And bank account.java. Yeah. Okay. The error is related to the imports, which it's not related to what we have, the change which we have done. We need those imports. That's the only thing, right? I think, yeah, local date and there is the stream. Okay, and just put the import there. Yeah, and okay, and okay, compile. Let's compile this. This dot date local return. Okay, I think we didn't change the return type there. So these are some other errors not related to what we have done currently. We didn't compile it yesterday at time, I think. That's a problem. Okay. Oops. This dot date. I've saved it, right? Which line is it? 62. Oh, this is local date, sorry. Okay, so it's compiling, right? Okay, let's understand what is working here, why it's working, right? So you're surprised with this, right? Uh, you know what is this \u and 4 hexadecimal digits? What they are for? Yeah. Anywhere in your Java file, right? You can use this is what is known as a Unicode escape. Right? When you write a Java file, anywhere in a Java, okay, it's a very simple thing. I'll first explain that part, okay, and then I'll come back here. Okay, fine. What are rules for identifiers? Yeah, valid identifier. How do you create a valid identifier? What characters can I use? Letters, fine. Digits, fine. Separator, separator like underscore, right? And so that underscore which we use. Uh, Currency symbol like dollar, right? Example is dollar. Yeah, and this is what we can use. Second rule says cannot start with a digit, and third rule says cannot be a keyword of the language. And this summarizes rules for identifiers, right? Okay, and this is one aspect. Okay, so let me ask you whether following is a valid identifier or not. How do I get it here? This is actually Windows has a problem. I don't have that font to show you certain things. Okay, I'll go to the J shell. I'm going to the Linux machine here. Just let me check if I can connect to it. Okay, it's not connecting. Yeah. Yeah. So fine, we can use letters, digits, and separator and a currency symbol. Okay. So suppose now, and anytime, fine. What we also so when we say digits, which are the digits you have? Yeah. What are the digits available? How many digits do we have?
Any number from 0 to 9.
Only means 0 to 9 human. This let me now. Okay, I'll explain it here.
Means these are the digits and we can make any combination out of that.
Okay. No, I'm talking of a single digit itself. Yeah. Okay. So now just check this. What do you think about a valid identifier? Okay. So I'm giving us this and tell me whether it's a valid identifier or not. Yeah. What do you think? Valid identifier? Yes or no? For example, someone says string. Okay. Your code looks like this. String S, not S. Sorry. string this equal to, and you might have something here. Okay, what do you think? This is valid or not?
No,
This is not a valid identifier. Why? What's the rule?
because compiler won't understand this language.
Why? Why compiler should not understand?
Because this language is not integrated into the compiler.
You know the character set? What is the character?
Yes, sir.
Yeah. Okay. What is the character set used?
Unicode and
Unicode. Yeah. You know the Unicode. So what does Java
Yes,
use?
sir.
What does Java use? Is it restricted to ASCII characters?
No, sir.
It's not restricted to the ASCII characters. Fine. So the first rule says you can use letters. Yes, these are letters. And these are all letters. They are coming from the Gujarati, and from the Gujarati block of that Unicode. Okay, the Java file which you are writing is actually a Unicode file. You can use any Unicode character in your Java file. Okay, fine. Okay. Now, just one more point was that, yeah. Okay. For example, someone. Okay, let me make it a little shorter here. Fine. So this one, Kemcho is a valid identifier. Okay, understand that. Fine. Actually, I couldn't connect to that Linux machine. Otherwise, on Linux, I could have shown this actually being done. On Windows, I don't have the forms to show you the things. Okay. Right. But yeah, this is a valid thing. Okay. Another thing here is, let me now put like this. Okay. Is this a valid identifier now? I placed the Gujarati digit 9. So yeah, I'm starting with a digit. So is it a valid identifier now?
No, sir.
No.
Because again, it is starting with a
It's
number.
starting with a digit. Yes, that's correct. And suppose I add that currency symbol rupee. It becomes a valid identifier. Fine, currency symbol. This is your currency symbol rupee.
Yes, sir.
Okay, fine. Now, suppose for rupee, I know, right? Suppose my keyboard has some problem. I can't generate that rupee character here. Okay, there's some problem with that input. What I can always do is, if I know the hexadecimal value for that Unicode character, in my Java file, I can always use a Unicode escape. Fine. A Unicode escape is of the form \u, okay, and 4 hexadecimal digits. And these are your code point value for the Unicode. Okay, fine. So, okay, now just come back to what is it that I wrote. I said \u 0063 LASS. Now, what happens is whenever we compile, the first thing the compiler does is looks for the Unicode escapes in this file. Oh, it is a \u 0063, and it will replace with the corresponding Unicode character. So this becomes 0063 is lowercase c. Okay, so this becomes class. You may write \u 0063, but it would be considered as a class. Okay, fine. So this is fine, and that clarifies the first one. First usage. If I show it again, yeah. The change in the account class, account.java, yeah, right? And I have highlighted that \u 0060, that is basically compiler will put it as C. Okay, what is \u 00AD? It is some kind of a space character, fine. Okay, but it's not in that ASCII part, but yes, it's actually some kind of a white space character. Fine. Okay, but one thing about this character, I picked it up specifically. Okay, fine. So if I'm putting it here, yeah. Okay, this is I just introduced. So backslash u and 4 hexadecimal digits, that actually means only one single character, right? It's not 6 characters. This is a single character for the Java file. Okay, but then is this valid? Is this valid? This shouldn't be valid, right? Okay, fine. So this is one more concept which I've actually put in this file. Okay, this is again related to the identifiers. There are characters in the Unicode which Java is mentioning as identifier ignorable characters. So in an identifier, if you embed them in between somewhere within the identifier, it will just ignore that character. Okay, so it falls in the category what we call as an identifier ignorable character. And if you want to check which character is an identifier ignorable and which is not, right, you can use that numerical value of a character and ask for is identifier ignorable. Okay, in the character class, this is a method available. I'll just show it on JShell. Okay, fine. Fine. Let's use JShell here itself. And okay, fine. If you know that a wrapper class called character is there, right? Character dot is identifier ignorable. So this will return true or false. Okay, and here I can give the value 0x and it was AD, right? Yeah, so hexadecimal AD, right? That's the value which I'm giving, and let's check. This is true, it's identified ignorable. Okay, fine. So if there is something which is identifier ignorable and falls within the somewhere is embedded within an identifier, it's going to be ignored. So you may write whatever you have written, right? But then it would still be considered. So in that code, if I come back, right? So even though I have written, it's like, okay, you have embedded this, but this is going to be ignored. So it will be looked at like this. Oh, sorry. I think, yeah. It will be looked at something like this. Okay. So this is just an additional character.
Sir,
Yeah.
what could be the actual use case for this Unicode characters writing in our code?
Uh, this okay, it's some kind of an obfuscation which you want to have someone else who is reading this code. For example, I can even do something like backslash u 0020. That's for the space, right? So I'm having a space character, but people will think, oh, what's been written? Can you read this now? Is this code readable at all?
No, sir.
Only you know, yes, what it means actually, right? For others, it's an obfuscation mechanism, some kind of an obfuscation which I do. Okay, fine. And
Okay, sir.
yeah, okay. Okay. And see, that would still compile. There's no space, right? It doesn't look like a space there. And that should still compile. Yeah. Okay, it's compiling. Fine. So backslash u, that's for Unicode escape. Plus another thing which I just pointed out was we have characters. There are many characters like this which are known as identifier ignorable character. In fact, this actually generates a space, kind of a space. It's Unicode is very large character set, and there are special characters like this also. They are actually it's a kind of a space character. And example, I think I can even tell you what exactly this character is. I won't be able to show that it's a space character in that moment, but the name for that can always be seen. Okay. And for example, I can use character The character class, I think you haven't used this much, right? Wrapper class called character. A lot of methods here. Dot of. There is some method to know the name of a character. Okay, I'll quickly go into the documentation and tell you where it is. Okay. Okay, we have the class called character and methods. Let me just look at the static methods here. Okay, code point off code point or something like that. Or if you need to get the name of the, so there's a method to return a string here. I'll just show that. Yeah, that's a method, get name. And give the code point value. There's a method called get name. Okay, so I can get the name of that character. Okay. Okay. And 0x hex, right? I have to give in hex, and the value was 80. Okay. It's a soft hyphen. Sorry, it's a soft hyphen. Okay. So soft hyphen here is a identifier ignorable character. Okay. And okay, you want to know the Gujarati character sets? Where is the Gujarati block? It's from starts from 0A 00. Okay, from 0A00 up to 0A 80. Sorry, 008 From here it starts. There are certain characters which are not available. Okay, I mean, there are some numeric values where we don't have a character basically. Okay, 0A85, that's a Gujarati letter A. So yeah, that should produce a A. On this, if I try that, fine. Okay, system.out.println. Okay, it won't be able to show the Gujarati letter A. Okay, fine. We don't have the font, it just puts a question mark. Let me try the rupee character if it is possible. 20B9. Yeah. You can get what it is, name for 20B9. Okay, fine. We actually have got two rupee signs, you know. A8 will also be a rupee sign. And earlier, before this sign was created, rupee sign for Indian rupee, it used to be written as RS. Yeah. So the other one produces, that's the old one. 20A8 is the old one, RS, rupees. And this one, 20B9, is the rupee sign. Yeah. But anyway, we don't have the font to show the character here. And so that's a problem here on Windows. On Linux, if I could connect, I could have shown these. Okay, fine. So when you write your code, don't restrict to using only the ASCII letters. For identifiers, you can use identifiers as you wish. And it should be, the rules are clear. It is letters and digits plus the underscore and the currency symbol. And all currency symbols are valid. Okay. Okay, what I'll do is I'll leave this code as it is. So, fine, and yeah, okay, fine. So let it not be readable by everyone. Okay, but yeah, it would compile anyway. And so all of you can try that this compiles. Yeah, so any questions? Yeah.
Sir, what will it return? U008 now?
Which one? 0 0 AD.
Yes, select.
It's
Select
AD,
yes.
AD. AD is the soft hyphen. This is one character, okay? This is one character. Whatever I have highlighted, that's a single character.
Okay, sir.
Okay.
Sir?
Yeah.
Sir, you told that we are not having the Gujarati font, so the Gujarati character is not fine. But if we want that font, so from where we can get, or in which directory we have to put that font?
Say on Windows, it's as far as the CMD is concerned, that command prompt is concerned, it is having very restricted number of fonts which are allowed there. Okay, fine. But here, I think here on this one, Shift Control U, 20B9. This is going to work. Yeah, that's working. Okay, but on command prompt, it's not working. Okay, but the other Gujarati font is not properly working, so I don't think Shift Control U 0A85 that should produce the letter. No, it's not showing. Okay, because there's an we don't have the font. Shift Control U, and I can give other character. Want to try some other character? Oh, you wanted to say 20A8. What was that? The earlier symbol was this. I don't know whether you remember this as a currency symbol sometime. And this was the old currency symbol for Indian rupee. Okay, and then it was.
Yes, sir.
Yeah. Okay, fine. So yeah, this is there. Okay, let me just put. Fine, because that won't be valid here like this. Yeah. You can declare variable, right? Okay. You want to declare variable with this as a because these are valid things. Okay. On J shell, no, it won't work because that's from the command prompt. On CMT, it's not working. That's those fonts are not available. Command has very restricted number of fonts. Okay.
Okay, sir. But if we work in ID, it will show the font.
Yeah, you should have fonts installed on your machine. That's one thing. Okay. You should have the proper fonts installed on your machine, and it should be available to your ID also. Then, yeah. Okay.
Okay, sir. Thank you.
Okay. Or you can work on Linux. That doesn't have problems. How many of you work on Linux? Anyone working with likes to use Linux? Because that's actually the it's good for the developers. From developers' point of view, Linux is much better. It's good for development. Yeah. Okay. And so yeah, any other questions? Yeah, then let's proceed then. Yeah. Okay. Fine. So from yesterday's exercises, any questions are there? Okay, fine. Then let's. So yesterday, I'll just quickly go through the stream part, right? So we saw about streams. That stream. Yeah. What are the? How do you get a stream? Creating a stream. Fine. Stream involves. Okay. So now, let's go quickly to this. Okay. Fine. We saw about stream. One of the simplest thing where we can get a stream is by using the stream method on a collection. And this is one of the most commonly used one. Okay. Fine. So calling stream method on a collection stream or parallel stream, right? We have that stream method. So that can give you the initial stream. And then on a stream, we use intermediate operations. Okay, a series of intermediate operations may be applied, and then it will ultimately we'll have to use a single terminal operation. Okay, the terminal operation gives us a result. Okay, fine. And gives result. Okay, and this one intermediate operation builds the pipeline. And so any questions related to these things? Okay, we have seen some of the I think in the slides I had shown that, right? We have those terminal operations also. Yeah, quickly someone wants to revise the intermediate operations. Yeah, which were the intermediate operations? Yeah, methods. Which are the intermediate operations? Filter would take a predicate as a parameter. Yeah. Okay. So this is, I'm assuming we are having method on stream of t. So it's a, your type parameter is t here, stream of t. Okay, for a stream of t, we have a method called filter which can take a predicate as a parameter. Fine. So that's for testing certain things, and it would return a stream of t again. Okay. Yeah, this is one method which is an intermediate operation. Yeah, which others? Distinct. Yeah, which one? Anyone recollects? I'm trying to list those where the size may get reduced. Fine, with filter, yeah, because of the condition, it will be, size will be reduced in the output side. Stream, see, it's returning a stream whose output side, right, which someone else will have to consume, right, from this. So fine. So whatever was the original source from where this, on which you are calling the filter method, is resulting in a new stream, fine, where there will be less number of elements, likely to be lesser number of elements. Yeah. Which other methods are such methods? They are just producing a stream for us. And limit, or I think skip is one. And this is skipping the initial. Long, okay. The number of elements to skip. Okay, skip then. Drop while to take a predicate. Okay. Okay, drop while then limit. And which one? Take while. And that again is a predicate. Yeah. And these are some of those intermediate operations where the size may reduce. But we have these intermediate operations where okay, yeah, this one uses a type parameter u, for example, and would return a stream of u, another type. Okay, and where method name is map. Again, this is a very commonly used method. We'll see. Fine. Map method. Yeah, parameter would be a function because it's a stream of t. The elements are of type t. So we have a function which for every element of type T, it can give me an element of type U. Okay, and so this is the mapper function. Right? So it can become a stream of U, it can become an int stream, map to int. Okay, okay, and this will be the toInt function. Okay, fine. And similar, just like map to int, map to long, map to double. Fine. There are other methods as well. Fine, which are the mapper. Fine. So they just convert from whatever it gets from the input into the newer type, and then it becomes a stream of the other type. Okay, and so and they require a function so that each element can then be converted. How it will be converted? Okay, fine. So mapper methods. Fine. Okay, and we had the method called sorted. Yeah, no, fine. Sorted can take as parameter a comparator of. I'll just put it as comparator of T. Okay, so that's your comparator needed. Okay, sorted would return the stream of T itself. It's not changing the type of stream. Okay. When it would make it sequential. And other methods are also there where we could say parallel, sequential, unordered. Okay, when all those methods are there. Yeah, fine. And then okay, another one was related to the method called flat map. Okay, so we have method okay, for some type U. Okay, it would return a stream of another type U. Okay, and method is flat map, takes as parameter a function from which can take one T and return a stream of U. Okay, fine. So that's our mapper function stream. Yeah, this is the mapper function. Okay, fine. Similarly, flat map to int, long, double. Okay, okay. Just so that you can understand, I think I'll take a different kind of an example by which you should be able to understand what is this flat map. Right. Suppose I was mentioning that we have a method. Now, this could even be tried out quickly on any kind of a file, text file. Right? If I have a text file, how do I create a stream of string out of it? Okay, let me create a stream of string. Okay, and we can get a stream of string. Okay. Okay, so it's a stream of all the lines, right, in a file equal to, if I want to create this from the java.nio.file package, or if you are more familiar and would like to use buffered reader, you may use that also. So you can say new buffered reader, okay, created from a new file reader, right? You can create buffered reader from a file reader and give your file name. Okay, and so you may give a file name and then just say dot lines. Okay, so this would return a stream of strings. So what are these what are the things which you are getting here in line stream? It's each and every line available as the elements from the stream. So stream is going to give me, the line stream is a stream which is giving me the one line each time, right? But I'm interested in working on the words which are available in a line. Okay, I would like to create a distinct map. Okay, a set of all the distinct words which have been used here. Okay, fine. So if you are interested in all the words in a file, distinct, fine. So my interest would be to get a set of string, okay, distinct words in a file, okay, equal to, and maybe you can, I would take this example. Okay. Let's take this. Yeah. Okay. Now after dot, maybe I'll put this in the new line. So one is dot lines, and then next, with this you are getting all the lines, right? And from lines you would like to now convert into a all the words which are there, right? So this can become a stream of words. It's a stream of lines currently, becoming a stream of words by using flat map. And what do we do with flat map? I need a function given a line, okay, I need to return a stream of words. Okay, arrays dot stream, fine, because it's an array which I'll be working on. Given a line, right, you can split white space. I think S is plus. Okay, so you are familiar with the regular expression? No idea about this? It just says any number of white spaces, right? So if you get white spaces, that's a thing to split. Fine, split method on a string. Okay, so this is now becoming a, and one more for the flat map to be over. Yeah. Okay, so this becomes a stream of string again, but now you have got the words. And what do we want to do? We want to just keep a count of it. That's my terminal operation. Oh, I'm not interested in count. I'm interested in the set distinct words. Oh, how do we get that? Oh, fine. Currently, I think the set we cannot use because we haven't seen the a few terminal operations. But yeah, it would be simple. Anyway, you can still do it without using the terminal operation if you like. Okay. For example, what we can do here is equal new has set. Okay, fine. And then we can just do like this. New buffered reader dot lines. Okay. So this won't return a value. Fine, dot for each. Fine. So for each, now what you are getting is a word, and given a word, we have distinct. Oh, you want to make it distinct also? Yeah. How do we make it distinct? Distinct dot oops. In for each, I have to write like this. Yeah. Okay. So you have populated in that set distinct words. You have populated all the distinct words. Okay. Fine. Given a line, so what you are basically giving is to the flat map method. You are saying, okay, given one line, okay, create a stream of words. To identify a word, we use the white space character. I think it is S or W. Mostly it is S. Yeah, yeah, S is correct. \S plus. Okay, so I don't know whether you have used the split method of string. Have you ever used this method split? String has a split method and takes a regular expression.
Yes, sir.
Yeah. Okay, fine. So you get the logic of this, what's happening in this? Okay. This statement up to this point is to create a stream. Okay, but this is a stream of all the lines in the file. Okay, from lines I'm getting into a stream of all the words. Okay, and then using the distinct. Okay, yeah, so it's still a stream, but on a stream we have the for each. Recollect there was that method called for each where we need to pass a consumer. So the consumer says, okay, if you give me a word, I'll just put it into the set called distinct words. Okay, so here's the function by which it would be adding into the set. And this function, you look at this as a function. You have given me a function. Okay, so for every element which comes to this level, right, in the for each, so what will be coming to this will be only the distinct elements. Is this clear? No, this code, because this is showing usage of string. Okay, this would be your whatever is your file name, and put any file name. Fine. So buffered reader has the method lines to return a stream of string. Yeah. Okay. Fine. Anyway, so this is just to get to into the mode of using a stream. Okay. How do we use a stream, and how, you know, with so little coding you can manage a lot of things. And the number of lines of code will be very less. Okay. This line here, okay, this line here could also have been written as, okay, you may comment this, and it could have been written as this, as far as this is concerned. Okay. Okay. And there's a single method invocation on an object. Distinct words is my object on which I'm calling the add method, taking whatever input parameters are there, right? Okay. Right. So here I've used the method reference. Okay. Fine. Now, fine. So you understand. Fine. You got an understanding about a stream. Basically the intermediate operation and terminal operation on a stream. Fine. If it's an intermediate operation, then you have a new stream, and you still have to do something more on that. Okay, which may again be another intermediate operation, or if you put a final operation, yes, then you are getting something. Okay, for example, in this case, the final operation was, or terminal operation was, the for each method. Okay, when for each is a method available in the stream. Okay, it takes a consumer, and we have given a consumer. Okay, fine. So now let's proceed with the advanced usage of stream, and we have some methods, right? So there are a couple of methods. These are again terminal operations. Okay, so which are the terminal operations we would like to discuss today? Reduce and collect. Okay, two methods, but they are anyway overloaded. Fine. So let me show you what is the reduce method. First one, a reduce method is overloaded. I'll first give you the one which can be good for introduction part. Okay. So on a stream of T, okay, if we have a stream of T, there is a method called reduce, okay, which would, so we have a public method. The reduce method would return a value of type T. Okay. Name of the method is reduce. Okay. And the parameter the reduce method takes, first parameter is a T, which you may call as the seed value maybe. And second parameter here is a function which is nothing but a binary operator of T. Okay, fine. This we call as the accumulator. Okay, so we use a seed and an accumulator. Okay. So yeah, to understand this, let me ask a very simple thing here. Suppose you have to write a method which can sum all the values in an array. How do you find the sum of elements in an integers in an array? What's the code you would write? Okay, let me put some part of the code. Okay, it has to return int. Name of the method is sum. Okay, taking an integer array. Let me call it as values. Okay, yeah. How is the code to be written?
Sir, we will start with a for loop, for each loop. We will iterate each items of array and add them into the block of code of for each loop.
Okay, straight away we will go for loop, or do we keep an initial value? Int.
Yes, sir. We need to start with an initial value.
That's my seed. Okay, I'm showing you what's my seed. Okay, and then what are we doing? A for loop, right? Okay, so it would be a for every element.
Array, so we can take a for each loop.
Okay, for int value in values. Yeah, and here what is it that we are doing? Add, right?
Seed plus equals to value.
Oh, actually, instead of seed, I should have called result. Result equal to, and I should have made something like this: int seed equal to 0, and here, okay, and you get the value point which I'm trying to make here. What is the seed value? Initial value. And what's that binary operator in our case here? It's a sum. Okay, fine. So we say result, okay, plus equal to value. And then we just have to say return the result. And so how result is prepared? Okay, now I'll explain the two parameters. Seed is your initial value. Accumulator, it's that binary operation which is to be done with the previous result. So seed is my initial result which I'm starting with. Okay, understand here. Okay, how reduce method is going to work. Okay, so when we use a reduce method, okay, we are taking two inputs. In the reduce method, there are two inputs. First input is a seed. Okay, so this is some object which is of type T. Okay, that's my seed object. Okay, and then I'm having a function, right? So I have a function, and so here let me keep this as my function. Okay, this function is a binary operator, right? It takes two input. First input is the seed. okay, which is assumed to be the initial result, okay, and second input is the first element which it is picking up from the stream. So I'll just call it as T1. It is of type T, right? So two inputs which are of type T, and it generates a T again, right? This is what a binary operator is. Okay, so this has produced a new value. This is my new result value, right? And then, okay, use T2, the second element from the stream, and give it to that same function. It will produce a new value. Okay, this is the new result. Yeah, this is my initial result, R0. Okay, this is my, it has produced R1. It has then resulted in R2, result 2. Okay, so like this, yes, it will ultimately, so it's like applying the previous result, fine, applying that method by using first input as the previous result and the next element from the stream, you get a new result. Use it in the next iteration as the first parameter. Clear? This is what reduce is doing. Clear? Fine. That's the way we have been working earlier also, right? Only thing is, yes, we were writing that for loop. Okay, so you just give two things, right? The only two things need to be specified. What is the initial result and what is the binary operator to be applied? Okay, give me that function which I can apply with every element. So just pass two things and that's it. Okay, it will give you the result. Fine, clear how it works? Reduce method, first form of the reduce method. And you can relate it with this, the loop which you were writing. You don't have to now write a loop. Okay, and you won't have to be writing a loop here. And you pass the function, accumulator function. Fine, clear? Okay, fine. Another form of reduce, the next one, okay, it returns optional of T. And name of the method is reduce. Parameter is the binary operator. So it just takes a accumulator. Okay. Fine. So if you don't give the initial result, there is a possible. So it's just working the previous, just like the previous case. Only thing, the first element which it gets from the stream will be considered as the initial result. Okay. So in case the stream itself is empty, then you don't have any value. So that's why the return type is optional. And that's clear? Return type is optional. So it's just like the previous one, previous reduce method only. Okay, fine. And the third one, now let's look at the third form of reduce. Okay, it uses one more type parameter. Now in this case, see, in the previous case, the stream was of type T and the result you were getting is of type T. Now in this case, the result is a different type. Okay, so result is of type U. Fine. So you will have, the method returns U. Okay, and the reduce method, okay, takes as parameter first element. Okay, that's like the seed. Okay, I think the term used is not seed but some other term. I'll come to that. But and you have a the binary operator. No, it's a by function. By function means two inputs. The first input will be of type U because that's my result type. Second parameter will be of type T, and what I'll be returning will be of type U. So UTU, okay, by function. It's a by function, not all three same. Okay, and otherwise it would have been a binary operator. So it's a bifunction, fine. Taking the previous result, using the next element from the stream to generate a new result. Okay, results are going to be of type U, fine. So this is what we call as a accumulator. But one more thing is, there's one more parameter to this. Okay, there's a parameter, this parameter is called a combiner, okay, which would be a binary operator. A binary operator of U. This is what we call as a combiner. Yeah, so there are three things needed here. Okay, three inputs in this method. So what is it? How is this working now? It needs a combiner. So fine. One thing is clear, the return type is different from the type of the stream elements. Fine. For example, someone is trying to find an average. The average is a result type which is different from the type of the elements, because the average would be of type double. My elements may be an integer type. Okay, so fine, what you are looking for, the result is not the same as the type of the elements. Okay, so that can happen, right? So for such a case, yes, we can use a reduce method which is of this form, and you have a third parameter. Let me try to explain what that third parameter is for. Okay, okay, okay. So it's like this. You have initial result of type U. This is my U is my initial result. Okay, fine. But what has been done in this case, fine, because we are using a combiner, fine. What can be done is your input, fine, whatever is your input, it can be split into multiple parts so that things can be done in parallel, right? Fine. You can process smaller parts separately. So divide your entire stream elements into smaller parts. Okay, it's going to be split. Okay, fine. So you can say there'll be one fine, your initial value which is of type U, so that's used by so processing of one part is taking place. So here one element of type U, other will be the element of type T. Okay, this is your T11, let me say T11. Okay, fine. And we have that bifunction, right? U and T are the inputs, creates a new U here. Okay, like this, yes, T11, and then we have one more element which is called T12. So segment 1, see, the first one is for indicating the part of the stream. So first part of the stream, okay, first element of that, second element of the first stream, first part of the stream. Okay, fine. Apply that function, come up with a new value. Okay, so what has been done is the entire stream has been broken into smaller segments, and for each segment a result has been created. Fine, a result would have been arrived at. So you are arriving at a result, fine. So you have multiple results. Let's say this is R1, because that's catering to one part of the stream. Second part of the stream also uses the same initial seed value, fine, but processes another set of, so this is your same value for U, okay, starting result, and this is another part which says, okay, I have T21, right? I apply that function, I'll generate one result, okay, fine, on which you'll again apply, you'll combine it with, you'll use the function, okay, so this is actually, this is the same function, okay, all these are the same functions. Fine. So these functions are taking as input the previous result and the new element to generate a result. Fine. So maybe here ultimately you get a result R2. Okay. So you got results R1, R2, they are of type U. Okay. And then you need to provide a combiner. So if I've got those partial results, right? These are partial results for the partial segment of the stream. Okay. So we need to combine them. So I'm saying, okay, use this function when you have to combine two elements which are of type U. Okay, how do I combine the results to produce the final result? Okay, yeah, so that's how the reduce method is working. Fine. So three forms of reduce are like this. Okay, fine, clear? Any questions on this? How reduce is working? The three forms of reduce. And they work on a stream, right? Okay. Fine. The accumulator and the combiner, two things we have used here. Yeah. Fine. Clear on reduce, then I can proceed to the next method. Collect method, yes, there are a lot many things in the collect method. Okay, and we'll see how a very little amount of code is needed for achieving a lot of work. And we can find to create okay, yeah. Any questions related to reduce? Understood or not? Yeah. What is this reduce method for? Yeah. Okay, see, you want to try to find out how to find maybe some the what's the minimum which is the account with the minimum balance. Suppose you want to find that account with the minimum balance. Anything like that or some such things? Okay, are there some to-dos also? There might be some to-do. I'm not sure whether I have given an exercise just for the reduce method, but there are more exercise related to the collect and the collector. Okay, fine. So from terminal operations point of view, yes, we have advanced terminal operation called reduce. Okay, reduce method has three forms. Fine, this is first one. This is the second one, and that's a third one. Yeah. Is this clear or not? I'm not getting a response. I'll just show it here, I think. Okay, so reduce, yeah, we call it as identity, not seed, rather it's called identity. Okay, fine. We can use that same term here. Anyway, it's a parameter name, so that doesn't matter as such. And the second form doesn't use an identity. Yeah. Is this understood or not? If it's not understood, tell me and ask the question then. Yeah. Anyone has a question here? No. Any questions are there? That's all. Is the role of accumulator clear here? What is it like? See, I can again relate here. Okay. See, if it was sum, you would have used what identity was. Okay. If it is sum, then identity is 0, right? If it was product of all the elements you wanted, then identity would be 1. The operator here, I should have used result equal to plus. The binary operator here is the plus operator. Okay, fine. Binary operator here is the plus operator. Fine. In the other case, this I can make 1, and here I can make multiplication. Fine. That would give me the product. So clear? You are using a different operator. Rest of the thing is the same, right? Isn't it the same? And this is how you were working. But they have just said, okay, these two can be parameters. Just parameterize this. What is the value for the identity and what is the operator to be used? Because now function is like an object for me, right? I have an object of a function. You give me what function, which binary operator function I have to use. Fine. But this is how it would do the processing. Okay. Fine. You don't have to write the loop statement. It's happening in the reduce method. Okay. Fine. But these methods would work on an object of stream. This is a terminal operation. And I'll proceed. Okay. Let's look at the next method, which is about collect method. Okay. So there's a difference, some difference and some similarity between some working related to reduce and the collect method. Okay. The collect method, let's look at the collect method, first form of collect method. Okay. So we have this public method returns. Okay, here okay, so your result is of type U, or okay, I think they've used a value R here. Okay, so result is of type R. R is your result type, and we have this method called okay, a type parameter R is there. Okay, returns R. Name of the method is collect. Fine. The parameter, the first parameter here is of type supplier of R. Okay, we call it as a supplier. So one parameter is a supplier. Okay. Second parameter here is a buy consumer of, it's a buy consumer, so two inputs, right? Okay. First input is R, second input is T. Okay, this we call as the accumulator. Okay, third parameter here is again a by consumer of r comma r, and this one is known as the combiner. Yeah. Okay. Right. So we have a supplier of our result is of type R. So we have a supplier of the R. Then we have a by consumer. It's not a function now. Okay. So the difference between the reduce method and the collect method. In reduce, we have a binary operator, the function, which is taking an input and returning a new value, right? Okay, right. Takes the old value plus the new value from another value from the stream and comes up with a new value. Okay, which then goes as a input to the next accumulation activity. Okay, whereas in case of a collect method, okay, the R, which is the result type, okay, one important thing about the result type here, R is mutable type. Okay, it is the R which is to be updated. It's the same value of same object of R which gets updated every time. Okay, fine. What it is doing is, fine, it's like saying, okay, okay, I think what I'll also do here, even for reduce, let me go back to reduce, fine, so that you have a much another kind of an explanation here. Okay, I'll do it for the last form of reduce. Okay, so when someone uses this reduce method, okay, the kind of coding which would be there inside this, okay, okay, fine. I'm not giving you the exact code, but you can assume something what is happening here is on this line. Okay, so it says fine, break into smaller parts, break stream elements. Okay, fine, it's like splitting, fine, so you get the split, fine, split is done. Okay, fine. Now on each part, okay, so I'll take first part, right? Okay, it will say, okay, let me have u, that's my result 1, equals, okay, I want to get the result 1. Okay, so for each part it's doing this. Okay, so it says, okay, r1 equals identity. Okay, fine. So this is identity, and then it says, let's have a for loop for each element in the, okay, in first string. Okay, let's say this element is t. Okay, the type is t for each t, or okay, I think I could have done that. Okay. Type t, this is my element, and this is representation of the first segment. Okay, first segment of the string. Okay. And what it's going to do here is, it's going to say parameter is accumulator, so it says, okay, r1 equals, right? So loops over the elements of the stream like this, right? So r1 is updated each time, input is r1 in that apply method. Okay, and once this loop is over, fine. So this is going to happen for every segment of the stream. Okay, fine. And within each segment of the stream, so you would have similarly R2 equals, okay, starts with that identity only, same value. Okay, but instead of first segment, it would have to process the second segment. So all the segments are processed. And let's say this is your R2, and that's going to be R2. Okay, so like this, it has got R1, R2, R3, R4. Maybe it has put into 4 parts. Okay, then what it will do? It will say, okay, now let me use U R is equal to, yeah, combiner dot apply. Okay, R1 comma R2. Okay, if there are more things, okay, fine. So it has got R1 and R2. Fine. Next, what it should do, maybe combine it with R3 also, R4 also. So it will say R is equal to combiner dot apply R comma R3. Okay, R comma R4. Fine. It can just keep on combining all of them. Okay, and then return the final result. If there are 4 segments, yeah, it would have done R3, R4. And getting the idea, find how this is working. The role of combiner, making it, breaking into parts and combining the partial results. R1, R2, those were the partial results, coming up with the final result. So for that, a different function is there. Okay, so on now, so here we have seen, find the if you want to distinguish between what is collector and this one, reduce and the collect method. In case of collect, right, it's the R which is definitely mutable, right? Here, it's a new value created for me each time, right? I'm using that accumulator dot apply, getting a new value and using the new value now. Okay. Whereas here, okay, I'll show for one of them. Okay. Fine. So R is definitely mutable. And why it is mutable, let's understand that. Okay. Fine. So it would be doing something like this. Starts with saying, okay, I have that supplier, so it is a supplier of R, so R, okay, R1 equals, okay, when you use the get method, you get the first element. Okay, so that would be the first kind of a statement. Okay, fine, but this is going to be done for one segment. I'm showing for one segment. Okay, next what it has to do is for each of the elements in the collection. For each of the elements in the collection, okay, which is of type T, okay, and that's your first part of the first part. Okay, and it would just be saying the parameter is accumulator. Accumulator dot accept. In this accept method, it says R1 comma T. See, it's not creating a new R1 for me. It has to be actually updating R1. In this loop, each time it gets a new value of T and updates R1 accordingly. Okay, fine. And then you got one R1. Similarly, you'll have R2 equals, and a similar thing would have been done. Okay, so at the end, when I let's say it's only two segments which I've got, then I'll be using, okay, R maybe is equal to R1, something like this I might start with, and I'll just say, okay, combiner dot accept, okay, R comma R2. R1 is already taken care because R is R1. I've taken it from, fine, and then return R. So you are basically accumulating in a particular, okay, when I'm saying this is definitely mutable, fine, the point which we have here is most of the time what would be used by most of the collect methods would be some kind of a data structure. So it's a data structure in which you are just maybe adding the elements which you are receiving. Okay, a simple example could be, okay, oh, I have these things, get me a set out of this, or get me a list from this. Yeah. Okay. You want a set or a list which contains all the elements. Okay, so fine. See, that same example which we had done for words, let me just go back to that word example. Okay, we had to do a for each, right? And we had to allocate an element. Let's not do a for each now, and let's go for a, it's not a for each which I'm using now. I'm going to use a collect. Okay, collect method. What are the parameters needed? First parameter, a supplier. And so I'll say, okay, my supplier is, oh, you want a set, right? So my supplier is has set colon new. Okay, so each time, fine, each part will be accumulated in a set. What is my accumulator? Accumulator says, given a word, okay, and that's yeah, accumulator is taking two inputs, sorry. It is a set and a word, set comma word. Okay, fine, because my return type is a set. Okay, this is giving me a set. R is set here. Okay, so I've said set and word. Okay, my function takes two input. First input is a set because that's my result type, and second input is a word. And what do I do with that? Set dot add word. Yeah, okay, comma, I have to give a combiner. What's my combiner? Given two set, right? So I'll say, okay, s1 comma s2. Yeah, given these two set, I need to return, I need to update the first set basically. So I can just even say s1 dot add all s2. Yeah, yeah, that's a combiner. It combines two sets. Fine, it has to update one of them, the first one, and fine, just update the first one. That's what is needed. Okay, here also it is updating the first element. First element is a set which is getting updated by calling the add method. Okay, fine. See, this line could have been rewritten by using a method reference. Yeah, how do we rewrite? On the first element, calling the add method to use the other elements. So we can say set colon add. Okay, this is set colon colon add. But I think no, this won't work because add method is returning a Boolean value. If it is to be ignored, that's fine. Yeah, return type was needed was void, but anyway. So this one, yeah, it can still work because if it's returning something and the signature requires that you don't want to use that value, it's okay. And so this should work. Okay, fine. So directly, then you don't need a, okay, you can just say set of string and whatever name you want it. Okay, we don't have to declare it separately and then that's it. Here, the creation of the set is not being done by us. It's done by calling this function here. Okay, we are not creating it. The collect method will use this function to create it. And it will create it for each part. And it will accumulate using this in each part. So it's this is nothing but accumulating all the objects from the stream into the set. Okay, but it is done for each part separately, and this is where we are trying to combine those parts. And so this is one form of the collect method. Okay, fine. The next form of collect method, okay, fine, this is the one public method. We have no. Fine. So okay, fine. A and R, there are two type parameters I'm using. The method returns result of type R. Name of the method is collect. Parameter is a collector of t comma a comma r, and that's a collector to be given. Oh, we have something called a collector then. Yeah. So this is the method of stream, a method called collect, which says give me only one parameter, but that parameter is of type collector. Okay. So what is a collector? Collector says, oh, I have got three type parameters, TAR, okay, and T is the type of elements to be processed. Mainly the type of elements coming from the stream. Okay. A is the accumulator type. Okay, which is mutable. And R is the return type. And R is going to be the return type. Fine. Okay. Fine. See, normally we discussed yesterday also, we use that unmodifiable list and unmodifiable set. So it's preferred that a method should not return something which is mutable. Okay, fine. So from that point of view, and this has been added. Okay, we have this. There are three things which are there are four things in a collector now. Okay, four. So what does a collector have? A collector will have uh, Okay. See, instead of passing 4 parameters, we have one object containing all the 4 items. Okay. And so collector is just one object which has got 4 items. What are the 4 items? So first item is a supplier. Okay. Supplier is a supplier of A. Okay. So we have which is nothing but something like we'll say, okay, the type is supplier of A. Fine. Second would be accumulator. So accumulator will be accumulating an accumulator. Okay. Okay. So it's nothing but a buy consumer of A comma T. When the type is by consumer of A comma T. The third element, first is supplier, second is accumulator, third is the combiner. So we know this also, right? Combiner for okay, and this here is a binary operator of A. Okay, and the final one, this is known as a finisher. Okay. This is known as it's a function from A to R, and this is known as a finisher. Okay, so there are 4 kind of functions used in a collector. Okay, let's see a collector. How does a collector look like? So if I have a collector, okay, it is keeping 4 functions inside it. Right? So we have one function which is known as a supplier. Okay, another function object. These are objects of function, right? Basically we know function objects because we know the lambda expressions. So one is a supplier. The second one is a accumulator. Okay, so stream elements will be fed to this. Okay, and then we know that because the stream is split into various parts, right? We will need a combiner to combine the accumulated values. So here is a combiner, and then we have a finisher. Okay. Finisher says, okay, I got the final result, final accumulated value. From that, I would return the value. Okay, and so ultimately, this collector is capable of returning a value of type R. Okay, here this will give you, for example, I use a supplier to always give me a blank, right? A blank set, an empty set. Okay, and then use the accumulator to add elements into the set. Okay, use the combiner so that I can combine the small sets which have been where the accumulation has taken place, and use the finisher to maybe return the unmodifiable set. From the set which I've got, I'll maybe return an unmodifiable set. So yes, I'm returning a set, but that set won't be modifiable. Okay, so you can use that finisher for that purpose, so that yeah, maybe you don't want to always return a modifiable thing, and fine, you don't want a mutable thing to come out. Okay, fine, but yes, so basically this is processing elements from a stream and coming up with a result like this. So result returned from a is of type R, and so this is how the collect method is. And what is a collector? Collector is made up of 4 elements. Okay, fine, there are some characteristics of a collector also, but yeah, and so maybe let's check this here. Yeah, okay, this reduce we have seen. Let's check 3 forms of reduce, and then here. Okay, fine, so here is the supplier. Find the first one where we have a supplier, a accumulator, and a combiner. Okay. And the second one says, yes, we have a collector of TAR. Okay, a collector is to be given. Collector is nothing but, instead of giving 4 parameters, yeah, 4 things in one object. So collector is that object which contains 4 functions. Okay, so these are the static methods which we can use to create an object of collector. And there's a method called of parameters, or these are the supplier, the accumulator, the combiner, finisher. And of course, there's something called collector.characteristics. The characteristics is an enum type, and it's a dot dot dot. So even if you don't pass any parameter for the last one, it's fine. It will take by default some characteristics. Okay. And so you can create by using 4 parameters. And here, if you are not giving that final third parameter, which is your finisher, okay, in which case it uses identity function as a finisher. Identity function is nothing but a function whose input and output is the same. You give whatever you give, it returns the same value. So that's also a function, right? So we have a function with which is your, yeah. Okay, so the second form uses the identity function. There's no, yeah. Okay. And so collector has these these are also methods in a collector. So if you have a collector object, yeah, you can ask for what is the supplier, what is the accumulator, what is the combiner, what is the finisher, and what are the characteristics a particular collector object has. So we have these are like the getter methods for the things which are part of a collector. Okay. And then here are the methods. So collector, fine. Yeah, this is the, how do I create a collector? So it looks difficult, right? All this looks quite intimidating. Oh, so far. Oh, there are four functions we have to create. Oh, we'll fine. In order to use this, oh, we'll have to create 4 functions. Okay, but we have a class called collectors. There is a class called collectors, and this is one of the classes which will help you to create a collector quite easily. It has only static methods, right, which help to create. Okay. Okay, so fine. Our interest is to use the collect method, how to get a collector now. Okay, so various ways of creating a collector. Fine. Okay, so collector for what purpose? Yeah, fine. So see this. What is the purpose of processing a stream? You're fine. You have elements of coming from a stream, and then ultimately you want to summarize and give something out of it. Okay. And so could be related to statistics or something. Okay. See, what was important in collector was the return type, which is nothing but your third type parameter. So now I'll show you some methods, static methods of collectors. Okay. And for example, we have the public and static method to give us, okay, it will see these, all these methods are going to give us a collector, and then we'll see the usage also, how to use it. Okay, so we have we can get a collector of t comma, it doesn't matter what is the accumulator type. Okay, but what I will be getting will be of type double if I am looking for an average. Okay, so we have something called a method called averaging int parameter to int function of t. Okay, fine. So this is your function. Yeah. So if you can fine. So if any element can be, you can convert it into an int. I will give you a collector which can then be used for getting you the average of all the integers. Okay. And same way, we have this similar method for long and double. Fine. It will be the too long function. Okay, here let me show the usage. Okay, fine. Now, coming to the bank example. Okay, fine. In the bank, we have provided a method. Fine. We were supposed to provide a method called get account stream. Right? So that would return a stream of account. Okay, so I'm assuming we have this method called get account stream. Okay, in which case what we should be able to do here is we'll say, okay, I want to find the average balance. Okay, and so problem is find the average balance. Okay, and how do we do this? So for example, let's say bank dot get account stream. Okay, and from this, yeah, what's the next step? Okay. So you can say double. Okay, okay, this thing. Okay, okay, so get the account stream. On that, I just like to call the collect method. Okay, and to in this collect method, I need to pass a collector. So to create a collector, I'll take the help of collectors. Collectors dot averaging long. And the type of the balance, right? Balance type is long, and therefore I want the average of those balances. And here is and that's a code done. You get the balance, average balance. Want to check in the test bank class whether this works? But yes, this is the code. See, you can convert into a what we say, fine. Given an account, I'm converting into the long value. Fine. The balance is of type long. Okay. And I want to get the average across all those account objects. Okay. So that's how you can do it. Collectors dot averaging long. So it creates a collector which can give me the average for the elements. Fine. Not directly the elements of account, because what stream is giving me is account objects, but from each account I'll pick up the balance and create an average for you. So, but remember this, we have to use the collect method. Collectors, this collectors dot this one, right? Okay, this is only for creating a collector which is capable of giving you the average balance, creating an average. And for that, the elements of the string from that pick up and convert into a long. That's why I'm saying averaging long. Okay, when I've shown averaging, right? So just like we have this method called averaging int long double. Okay, and used for finding. So if there was, here balance was the one on which we were looking for average. Okay, finding the average. So we use the averaging long method. Okay, so whatever your type of attribute may be for on which you would like to know the average, right? You can use if it is of type long, or if it is of type double, yeah, averaging double, or type int, you can say averaging int. Okay, and then accordingly that method has to be there, right? The two long function, two int function, two double function, that has to be used accordingly. Okay, and the static method is there. Okay, so fine, we have this method called averaging. Just like we can say averaging, we can use summing. You can also use summarizing. We have summing, exactly same thing. Instead of average, I can give you sum. Right? So it's a repeat of the three methods here. Okay. Only thing, yeah, the kind of results which you will be getting is different. Okay. So on some attribute, okay. Okay. So on some attribute, okay. Now if I'm looking for sum, the sum will be of type long, even though I'm using two int function. So values are integers, but when you ask for the sum, okay, it will become of type long. Yeah, this will be long only. Instead of averaging, use summing. And in case of type double, if you ask for the sum will be of type double. Okay, fine. I can repeat the same three things, and we know that if we got those summary statistics. Fine. Yesterday we saw those summary statistics classes. So yeah, the result will not be a long, but rather a int summary statistics, or even int summary statistics can be generated. Just say summarizing. Okay, and so it is summarizing int. Fine. So the result type is going to be a summary statistics. And this one, and the result type is a long summary statistics. Long summary statistics, and that will be Yeah, fine. So it's a repeat of the same things. Okay, fine. You can try out maybe the summary statistics thing, fine, on the bank test bank. Fine. Quickly, let me just show it to you how it works. Okay, so let's make the required changes. I think the adding of the stream methods was there, right? Already done. Fine. The get account stream and the get the streams was already done. Let's use the test bank. In the test bank, yeah. Okay, here are the to-dos, right? I'll just pick up, I'll not do all of them now. And yeah, I'll pick up the add a method to in account class. This is done already, right? Add a method in account. Okay, yeah, we can add this method in the account class called has penalty. Okay, if the account has any penalty transactions. Yeah, can we do this? This is to be done in the account class has penalty method. How do we add that? Yeah, here also I think the same to do has been repeated here. Okay, so we want a method called has penalty. Whether so on account I can say, oh, it has some penalty sometime, and it did have a penalty. So if I want that, okay, this is for getting, okay, let me put it here. A public method returns boolean, has penalty. Okay, yeah. So how do you check it has a penalty? See, you got all the transaction objects, right? Okay. They are available in the form of a list. That's a passbook. So examine the passbook. This dot passbook dot stream. Let me put it into a stream. Okay, it's a stream of transaction, right? Dot. If any one of them has a penalty, if any of the transactions, any even single transaction has a penalty or not, right? I just want to know that. How do I know that? Any match. Recollect those methods. All match, any match, none match. They return a Boolean value. So yeah, I can just put, I'll say return, okay. And I'll put the function in the next line. What's a function? How do I test? Given a transaction T, how do I test whether it has a penalty or not? T dot get type. Fine, so transaction type, I think, and that's equal to when it's our enum, right? So or I can be more specific and say trans type dot penalty, and that's our enum object. Yeah, so that's it. See, and so we just added a method called has penalty. Okay, let's just compile and check it's compiling or not. Penalty is not there as a transaction type. Okay, Okay, yeah, okay. That penalty as a, we have debit and credit as a transaction type. Okay. We have narration as penalty in that case. Yeah. T dot get narration, right? That equals. I think. Oh, sorry. Because I thought we had a type. Fine. Okay, fine. This is what is the change, and you can try compiling. Stream import is missing. It's in which class that error is? Bank. Okay, for class bank we have to update. Yeah, we didn't compile this in the morning. Okay, it compiles. Now you want to use it in test bank, or even in account you can write that code. Okay, we'll go with the to-dos and whatever is there in the to-do. Okay. So first is update the class to use a map of law. Okay, this is done. There was a to-do. This is the bank class. Okay, I think we have that exercise. The to-do is written in the test bank. Okay, so this is done. Okay, display all accounts which have a penalty. Can we do this now? Display all accounts which have a penalty, and that's a code which I was writing there, which is very similar to this. And we have done list accounts, and then okay, so here let me put it just immediately following this. Okay, bank dot display all accounts which have a penalty. Yeah, how can it be done? Bank dot get account. Okay, you got the account stream, and you are only interested in which kind of account objects that have a penalty. So what should be done? Fine, we can use the filter to say as penalty. Okay, so it gets filter. Okay, so only those with the penalty will come, and then we are interested in printing all of them. Okay, just say dot for each println. That's done. Let's compile. Let's run the code. See, after the end of account list, the two lines which are coming, those are the ones, the only two of them who had a penalty. Okay, and so it's printing the two of them who have a penalty. But see, this is the code. You're seeing the amount of code to write. Otherwise, how much code would you have written for this? Even that has penalty, that method. the lines of code that goes otherwise. Get list of accounts with penalty. You want a list of accounts with penalty as a list, fine. Okay, fine. We'll see. There are more methods for. Okay. If you recollect, there is a toList method in the stream. List of account, okay, equal to, and how do we do this? Bank dot get account stream. Okay, we just wanted that stream. Okay, and dot, yeah, filter as penalty. Okay, I'll put it in the next line. Dot toList. That's it. Okay, toList is a terminal operation. Okay, sort the list on different criteria. Anyway, that can be done. That comparator thing has to be used here. Okay, create the collector using the 4 components and get summary statistics for all the account balances. So you want statistics of all the balances. Okay, let's do this one, and we're looking at that. So we'll say long summary statistics. Okay, balance statistics equals bank dot get account stream this in the next line. Okay, get account stream dot, now on this, yeah, what do we do? It says get summary statistics for all of them, so there's no filtering or anything, right? So we just go for collect. Okay, and parameter is collectors dot summarizing long yeah, and so this is done, and you want to print it. Okay, let's print this. And there's a good toString method for the summary statistics object, and we should be able to see that. So long summary statistics, here it is. So count, there are 18 accounts, fine. Sum of the balances is this, minimum balance is this is the average balance, maximum balance has been this much. So giving you all the statistics. And here are the, actually this was the listing which was done. So you can confirm the minimum, that's 1100. Okay, fine. So that summary statistics object here. So we have a collector. See how easy the creation of a collector is. Okay, get the account with the maximum number of transactions. Get the highest transaction amount. What's the highest transaction amount? See, in this case, we will have to work on the transactions, not on the account. Okay, Get this, fine. So for that, what would you do? First part, let me just give that. Get the highest transaction amount, right? So it's of type long. Equal to Vanguard get account stream. Okay, fine. So this is a stream of account, but I want to work on transactions. So what should I do? Dot. Okay, I'll put it in the next line. Each operation, let's do it in a separate line. Dot. Dot flat map. In flat map, given one element of account, I need a stream of transaction, right? And that will be account get transaction stream. We have done this method also, right? Get transaction stream, and we've added it yesterday. So this gives me a stream of transaction, and on this stream of transaction, yeah, we want the get the highest transaction amount. Yeah. So the different ways you might start from here, because this is where you have all the transactions coming for you. So how do you process each transaction? You want the min. And so there's something called, okay, but this will give you an optional long. Okay, fine. The object will be an optional long. Fine. Dot. We may assume at least one object is there. Okay. Fine. Or else, yeah, we can use even or else also. Yeah. Fine. So how do you find? What's the highest transaction amount? Here you might go for map to long. Okay, convert each element to, okay, I want the long value. I'm not interested in the transaction object, but the amount object. Okay, it's an inner class of account, right? So on each account transaction object, invoke the sorry, it's account. Sorry, no, this is a transaction object. Okay, get amount. Okay, so that's the amount, right? So now you have a stream which is having long values, which are the amount values. This is a long stream. Map to long converts into a long stream, and then from this long stream we can just ask for the min. Okay, we have a method called min. Okay, so that gives, this is a terminal operation on the long stream, in stream long stream, but the return type here is a optional long. It's a optional. On optional you can use the method dot or else. So if you don't find anything, okay, let's consider it as a 0. If I don't find anything, assign a value 0. Fine. Because it's optional, you will have to use some method. You could have said get if you are sure, okay, there is at least one element. Okay. Fine. So this is how you are getting the highest transaction amount, and you can print it. Oh, we did min, sorry. We had to do the max. Okay, anyway, so min has worked, max will work, yeah. And so this is the highest transaction amount. Fine. So this is also fine. It's similar because we were able to create a stream of transactions. So on that, we can just ask for the long summary statistics. Okay. Summary statistics for the transaction net amount. Fine. That can be done similarly using grouping by. So this is the next method which we have. I'll push it here. Okay. Fine. So those were the methods for average, sum, or summary statistics, and that's what we have seen. Okay, we also have another interesting method called grouping by. Okay, and so how this works? See, for example, I'll give the example here from the account class. We have all the account objects, right? And we know that name may not be unique, right? In these account objects, there might be two account objects with the same name. Okay, so what I want is a group of objects. Okay, it's like saying, okay, for this name, I want a map, basically a dictionary. Fine. Given a name, give me the list of account objects. Okay, given a name, give me the list of account objects. So for that, yes, the method which we have, okay, and this is something which is again giving me a collector which can help me with this. Okay, so it's going to return type is going to be a collector. Okay, static method returns a collector of t, because yes, it will be processing elements of type t. Okay, we are not bothered about the type of accumulator type what is used, but what will be the return type? For return type, I want a map of k, comma, list of t. What is k here? K is the type of elements. I have not mentioned the. Okay, I'll show what exactly it is with when I put the method here. The method name is grouping by. And what's the parameter? It says you just give me one function which converts an element from t to k. Okay. This we call as a classifier. Okay. So as an example, I want a map of string, comma, list of account. Okay. So this is name wise accounts, right? Okay, so for each name, give me a list of account. That should be a map. I want the map to be created. Okay, and let's see the amount of code we need to write for this. Bank.get account stream. Okay, and dot collect. Okay, and we'll have to create a collector. Collectors dot grouping by, and okay, so I'll write it with the. That's sufficient. This is done. Okay, fine. So you can get a map like this. Name wise accounts. See the amount of code needed. Okay, want to test this? Okay. Yeah. Get a map of name wise list of accounts. Okay, let's put this code here then. Okay, and so this will be returning a map, but then I'm interested. Let me print it, right? System out println. Okay. Here it starts after that highest year. So here is a map, right? In the map it says James, so that's a name equal to, and in square bracket it is giving me the list of objects. Oh, there's only one. For James there's only one. For entry there's only one. Yeah. Saina there's only one. Okay. Jugal, yeah, we have one. Tina is one. Deepika is one. Tilly is okay. One. Nidhi is Salman. I think there are two Salmans. Yeah. Yeah. And this is the first object of that's a savings account, and the second one is also a savings account. Okay, with Salman. So fine. So we have a few where we have the more than one element. Salman is one where it is repeating, and anyone else is repeating. Yeah. Okay. Fine. We could have actually printed this in a different way also by writing a for loop. I want to print it with the help of a for loop. Okay. And you want to do it that way? Yeah. So you could have done even like this. Okay. Name wise. And name wise accounts. It's a map dot. What we can get? Entry set. Recollect there's a method called entry set. Fine. It's a set of entry. Entry is a key value pair. Okay. Dot, and then I can use a for each, and I can say system.out.println. Okay. So each one of them I would like to apply a println, right? And I'll say okay. Okay. Now or each. Oh, sorry. When I'm passing a for each, here I have to pass two parameters first. One is the key, comma value. Value is the account object, so I should put name, comma account. Okay. And oh, it is a list of account. Name, comma ACT list. Account list. Okay. Given these two, system.out.println, and okay, we can say name plus equal to keep a equal to, and plus ACT list. Okay, so this is println, and that's for the for each. Yeah. Okay, so could be printed in this way also. I'll comment this one, and yeah, this is how we are printing. And so it's oh, sorry, I think what we did dot for each. There's some bracket mismatch or something. Oh, sorry. Yeah. Here it's not name, comma. It's only one parameter. Recollect. Yeah. This would be the entry. Entry. Yeah. Yeah. Okay. entry dot get key, and here it is entry dot get value. Okay, so now at least it's every name starts in a separate line, so you can make out easily. Okay, which are the ones with more than one? There's only one. Yeah. And but it's like name wise list of account. Okay, it says get a partition of accounts. Now just like we have a grouping by, we also have a method called partitioning by, which is in partitioning by, instead of this we have to give a, so okay, actually there are more variants to this grouping by which I have shown. Okay, so let me talk about the other grouping by method. Okay, and so we can do much more than what we have done. See, what we are seeing here, okay, is a key, and we have a name, and for that name there is actually a list, right? Now you were to do some summarization on the list also. Okay, fine. So I don't want to see the list. Instead, give me the balance which they have, the sum of the balance. If there are more than one element, just keep the sum of the balance. So for this name, what's the total balance? Okay, fine. We have a list on the other side. The value side is a list. So you might like to actually summarize on the list. So if you want to do summarization on the list, fine, we have this method being overloaded. So other than classifier, one more parameter may be specified here. Okay. I can do this, that here I'll break this into the next line. Okay, where so one parameter is the function, other parameter is a collector. So you can give another collector. Okay, because it's a list of t, right? It's a map with k and list of t. K is my classifier type. Okay, so it's a function where I'm converting account into a string, so it's a string. K here is a string in our case, in our example. Okay, and t is the account object. So it's a list of t which I want to summarize, and therefore I must give a collector of t, doesn't matter what is my accumulator type, and the value type can be something like d, some other type. Okay, fine. So this is fine. So we say this is my downstream collector. Okay, so we have a downstream collector to be passed. Okay, so if you do this, the mapping will not be with the list, but it will be with, by summarizing using this collector. Okay, fine. So let's give an example of this now. Okay, yeah. So we had done the first parameter, that was fine, but we will have one more parameter. So in the collect method, there are two parameters we are having now. Sorry, in the grouping by with two parameters. Yeah, here grouping by has one more. This comma goes. Yeah, grouping by has one more parameter, and that parameter is to get a collector. Collectors dot you want sum of the balances, summing long. Okay, and here you'll ask for the, you look for the balance. Okay, and summing long takes parameter as t and returns long. So t here is account, and I'm returning get balance returns a long. Okay, and want to try this. Oops. Okay, I'll just add here before we go to the partition by. I just wanted to show this. Yeah. And so we are using grouping by and giving two parameters. Earlier it was only one parameter, one function. Parameter here are functions. You can see that. And it's a function to convert a count into a string, which is giving us the name. And now we are saying for from the list of don't map it with the list, but instead of list, okay, create the sum of the balance. Okay, balance you can get with the help of account colon colon get balance function. Okay, and then we want to print this. Okay, it's name wise balances, name wise accounts becomes name wise balances. Balances, when I'm saying, it is sum of balance basically. We can use this one to do the printing. Okay, let's print name wise balances. Grouping by, and there are two parameters. Collect, and then you set collectors dot grouping by. Second parameter is the TAD. Let's just check what's the problem. Okay, here we did copy paste, but so we didn't change this return type. This is long, right? Name and balance. So balance, sum of balance is long. And oops, sorry, compile and run. So name wise sum of balances, right? So this would normally be just matching whatever was there earlier. And when we saw the list earlier, their balances would be matched, except for in one case, it would be the sum of the two things, two fields. Okay, 7123810 and 110010. Okay, let's check sum of those two things. Oh, sorry, the sum is here. Sum of this 8000 and this 170. Yeah, so that's correct. 1.5. 7 plus 8 lakh, 15 lakh. Yeah. Okay. And so I think it's coming 15 lakh. So correct. Okay. And now, just like we had the grouping by, we also have a partitioning by method. Name by sum of balances. I think this is get a name of some. Fine. This is that method, right? This is that method. And so yeah, we have done it already. Yeah. Okay. Okay, so get a partition of accounts with and without penalty. Right? So partitioning by is exactly similar to the grouping by. Okay, so this also generates a map, but it is we are using a classifier, right? When we use the classifier, we are saying okay, it will convert into some type k. Okay, when function was from t to k. Okay, if I look at it here. And in grouping by, we were saying function from T to K. Okay, and this is the classifier. There, the classifier changes. Okay, we won't have this anyway. Okay, so let me pick this up and just see what is the change. Okay, yeah, we have our classifier instead of classifier, which is just observe the change here. You will know what I'm talking about, right? It's a collector of a map of no k here. Key is always a boolean, and it is the list of t. And instead of grouping by, we are saying partitioning by. Partition into two, okay? Where it is true, other where it is false. So this is partitioning by, and it's not a function, it's a special function, which is nothing but a predicate of t. So predicate of t means, oh, input is t, output is boolean. Clear? So this is your predicate as a test. Okay. So we wanted to do partitioning based on. Okay. Fine. So let's see this one. How do we do the partitioning? Map of boolean, comma, and here is the list of account. Okay. And because this is simple partitioning by, here also the same thing, you can add that second parameter also. Okay, actually as far as grouping by is concerned, there's one more overload which is available. Okay, because it creates, which implementation of map will be used is decided by the method, right? But you want to specify what implementation of map to use. That is also possible. You can control that. Okay, so that way the overloading has been done. Okay. So we want partition of account with or without penalty. Is equal to yeah. Next line, you can take this and get the stream dot collect, and we'll use the collectors dot partition by. Okay, so partitioning by, okay, I want to partition based on the has penalty or not, right? Has penalty, and sorry, here partition, this is okay. And this is for the partitioning by, and there will be one for the collect. Yeah, one bracket for the collect. Okay, so this has created a map, and let's print the map in that same way by using that for each on the entry set. Okay, I'll show you one more because there's a default method. Earlier, you recollect I was trying to use name and those two things. So that's also a method, but I'll show you how it is to be used. Okay, I'll use it here. Okay, so here is the penalty partition, which is a map. Okay, now here directly on a map also a for each is available, in which where the two parameters are given. Okay, so here it is partitioning the account objects based on, so okay, it's a boolean, right? True false, b comma, and okay, list. Okay, and recollect I was trying this one at that time, or here it may be better with the other case. Anyway, and yeah, so given this system.out.println, okay, what do we want to print? Given a boolean value, and so b plus equal to plus and list. This is the one for the for each. Yeah. Okay, so this should work. Dot. Okay. Yeah, before this there must be that true and false. True equal to, and before that there's a false equal to. When it says false equal to, and that's a whole list, big list. And true equal to, I think there's only one and one, two of them. And Josh and Jinal. And they are the ones who had a penalty. Others didn't have a penalty, so that's a bigger list. So true equal to is a bigger, false equal to is a bigger list, right? Has penalty, no, false. And has penalty, true is this one. Okay, so this is what is partitioning, right? Map. True, false, just divide into using true and false. Okay. And sort the list on different criteria. So one can attempt this. Okay. Yeah. I think I written the code in the notes probably. Okay, I think you can attempt it on your own, right? This one. Okay, let's go through the slides there because there are a lot many other methods as well. Okay. And, these were those methods I think which are related to and averaging, summing, summarizing. Okay, and these are the ones which return a summary statistics, right? And we even have the min and the max counting. See, there's a method just called counting. Okay, so this counting is uh, giving you a like a collector. If it is used in the collect method, will give you the count. Right? So return type is long. Count return type is long. Right? Min by. If you say min by or max by, use a comparator then. Right? But the return type, you can see that it becomes an optional of t. Right? Min by, max by. Okay. So these are, we have a min and max method in the stream, but min by, max by help you to create a collector, not directly the result. And we understand like there is a downstream collector which is used in many of the methods of collectors class, so it could be useful there. Okay, so here is a method called this one is collecting and then. Okay, this is mapping, collecting and then mapping. There's a flat mapping. Flat mapping is more like using the flat map in the stream. So you here, if you have not used flat map in the stream, you may give it while creating the collector object. Okay, so that it can create the flat map. So you can see flat mapping, and it is taking that same thing, function t comma stream of u. Fine. So this is what was there in the stream class. The intermediate operation called flat map. This is so this one is helping you to create a collector, right, instead of applying the flat map straight away. Okay. Right. Yeah, we have this method called okay, fine. The first two, let me explain those two also. There is one called collecting and then. Now you can see collector, it takes two parameters, right? One is a collector, which is a downstream collector, and then a function, which says is a finisher. Okay, fine. So if you want to just understand this one, okay, it's something like this. And same way, there is a mapping. Fine. So mapping says convert to T to U and then use a collector, downstream collector. First it is a function. Right. See, if you look at this collector, it's like this, right? This is how a collector looks like. Okay, so if you have this as a collector, what that collecting and then is saying, okay, you can create another collector. If you got a collector like this already, you can create another collector. Okay, fine. Where, okay, whatever this collector was returning, it was returning R. Okay, from this you are using one more function over here, adding a function so that it becomes a double R. So you are adding an additional finisher to this. Okay, so whatever finisher earlier was giving was R. Okay, I'm giving you another function. You use that same collector. I'm giving you another function so that your return type becomes, so it becomes a collector whose return type is double R. You can see this. See, this is what that method signature is. Look at this. Fine. It says returns a collector of TA and double R. That's what the collector will be returned. Input parameter, first parameter is say TAR. And what's the second parameter? A function which converts from R to double R. That's you are adding one more finisher function to it. Okay. Fine. So that's what it was doing. Okay. The second one also, the second method here, which says mapping. Okay. So what is mapping doing here? Fine. I think, so mapping is something on these lines. Fine. Quite a similar thing, but it's on the other side. See, I have a collector, right? This is a collector where it processes. We understand this is there is a supplier, but see the elements to be processed. What's the input? Input which is coming to the collector, right? okay, is of type T. That's used by the accumulator. Fine. Not a, yeah, accumulator function. Combiner was combining accumulated values, but then we had a finisher to return R. Okay. A is used internally in a collection of TAR. This is a supplier of A, and this is a combiner for A. So these work on A. Interfaces, stream elements are of type T, which are fed into the accumulator. Finally, it will be coming out with a result R. Okay. So what it is saying, yes, instead of T, he's saying, okay, let's have U over here. So it's a collector which collects from U to R. And if you look at that method signature, we'll just go back to that method signature, and yeah, if you look at that method signature, what it says. Okay. Fine. T to R is what will be returned. Fine. The collector which is there is U to AR, right? It's UAR. So input is U, stream elements will be U and R. But I'm having a function which converts from T to U. Okay, so it says fine. This collector processes elements of type U, and what you do here is you are only adding a functionality on top of this, which is converting elements of type T into U. Okay, so a function input is T, output is U, and here is a collector which uses U. Okay, fine, I can do this. So this becomes so if I combine this additional function over here, it becomes a collector which is which process elements of T and returns R. Your earlier collector was for U, but now I have this collector created by combining it. And so we are combining basically in front of by adding a function. Okay. Fine. Flat mapping is for that other purpose. Same way, just like we have a flat mapping, you don't want to filter in the stream, you can do filtering within the collector itself. So collector takes the functionality of filtering. Okay, so flat mapping, filtering, okay, those methods are on those lines. Again, same way, reducing, we don't want to do a reduce, right? We will have a collector which will do the reducing job. Okay. So, it's the same parameters as was required for the reduce method is what is taken by the reducing method, right? But it creates a collector and does not give you the result. Okay, right? It won't directly give you a result. It's giving you a collector which, when used with a collect method, fine, will give the result. It may be used with a collect method. It may be used as a downstream parameter to another method of a collectors. And so it's giving you collector here. Find three forms of reduce, and we have a method called teeing, T-E-I-N-G. Okay. So what is teeing? Teeing says, okay, you got two different collectors. One collector is processing elements of type T and giving a result of type R1. There's another collector which will also process the same elements but gives another kind of a result. So you have two different collectors, and if we have a method, if we have a function added to it which takes two inputs, which are nothing but the results of the two collectors, fine, two different collectors, then we have a merge function, and this is okay. So this was added in Java 12, basically, this particular method. Okay, fine. So you are having a merger function which merges the results of two collectors. And just adding one function to it, by function, takes R1, R2 and returns R. Okay, this is that grouping by. Okay, you can see, fine. First two I had already discussed. The third one is actually about having a supplier for the map. So which map to be used, and which implementation of map to be used, the invoker can decide that also. By default, it would create a hash map, but I want a tree map. Okay, fine. Then use this parameter for the map factory. Okay. Hmm. So, like we have grouping, like we have a map, there is a concurrent map, right, which is more more useful in case the map is going to be used in a concurrent fashion, like okay, multiple threads working on the same map. If that is the case, don't use the normal map. Try to use the concurrent map implementations. So there is one interface called concurrent map also. It's part of java.util.concurrent package. Okay, so this is that same grouping by, but for concurrent map. And here is that partitioning by. Yeah, we have seen partitioning by already. And okay, here joining. Yeah, three forms of joining. What is joining? Yesterday we saw the string joiner. So here it says, fine, if you have a stream of string or stream of a char sequence, fine. See, here it's not saying T, it's very specific. It's saying char sequence, the first type parameter. So you will get a collector which will process elements of type char sequence, not just any element T. Okay, and will return a string to you. Okay, by joining all the character sequences which it is getting. And just do a concatenation. Okay, fine. And second one says, yes, you may specify a delimiter. One string, if you give a char sequence which is a delimiter, yes, those will be separated by a delimiter. And if you like, you can also give, along with delimiter, the prefix and the suffix part. Okay, so this is a joining method working only on the char sequence type. Fine. And here is the method. Yeah, these are some other useful methods. You can convert into whatever stream elements are there. You have a collector which can help you to create a collection out of it. Fine. So maybe you want to create a linked list or some other thing. Okay, you can do that. Object of linked list type, right? Or any other specific class whose object you want. So give a supplier for that kind of a collection. Okay, or you can ask for to set, and there is also the method to unmodifiable set. So elements will be, this collector helps you to create a set. Okay, to list, fine. To list available here. There's also a to list directly in the stream also. That actually was added later, which is there directly in the to stream. In the stream interface, the to list method was added in 16, Java 16. Okay. Here we have to list, and which is there available even in the previous version. So you could actually, earlier we had to do the collect method and call the collectors collectors.toList. Okay, but now stream.toList, that would work. Right? So you may use Java 16, 17, then it should work. Okay, and we have another method just like that. We to list, we have the to unmodifiable list, and here is the method for yeah, okay, this is for converting into a map, to map. Okay, right. So see, what is this to map? Fine. What it says, the elements which are coming from the stream, you find for each element you provide two functions to me. Okay, one function from that object, fine, which is the object from the stream. You want to generate a map, fine, from that object. Tell me which attribute can be, what thing can give me the key part to be used as the key, and what can be used as a value part. Okay, fine. So this is nothing but creating a map by just giving two functions from the stream. Right, that first one. Fine. It takes two functions. Function is a key mapper and a value mapper. So one function given a t returns k. So that's my key type. Fine. So you can see it's a map of it's returning a collector of t question mark map of k comma u. Okay. So key mapper returns from t returns k, and value mapper returns from t, it returns u. Okay, fine. Now what can happen in this case, the first method which we are seeing here, this first method can throw an exception. If the same, you are mapping element to a key. Now, if that key is repeating, fine. If your function generates the same value again for another element, okay, then it will throw an exception. Okay, fine. So if your key mapper should ensure that is generating a unique value. But sometimes maybe it's not able to generate a unique value. For example, if someone was trying that with our name, okay, in our example, if the name was being tried, yes, we have two elements with the same name, right? Two account objects with the same name. So in such a case, you might like to use the second form where what we are saying is, fine, key mapper, value mapper remains as it is, right? So value is of some type u. Now we have a binary operator of u. What is this binary operator of u? Okay, if for the given key, I already have this in my key, right? So if for this key, another, I'm getting it for the second time, okay, the same key is being generated, then the value mapper, whatever value it has generated, fine, you have an old value for this key, okay, so give me a binary operator, right? So given the old value and a new value, generate another value. So if someone wanted to do the summing, yeah, summing could have been done with the merge function. Fine. Or someone was saying, okay, whosoever out of these two has a higher balance, I'll map that account object or whatever it is, right? So you can decide your merge function here. Okay. And the third one is only about giving taking control of which implementation of map to use. So that uses a supplier. Okay. And same three things will be there for concurrent map. Okay. Fine. And also the unmodifiable map, I think. Yeah. We can even have the unmodifiable map. Okay. Okay. Date and time, I think we had yesterday I had given it in the slides. Yeah. We are short of time again. Yeah. Any questions? Yeah. Yeah. Anyone has questions? Yeah. Okay. Yeah. Anyone else? No. Okay. And then yeah. Yeah. Okay, fine. Then fine. So let's call it a day. Yeah.
Sir, first of all, thank you so much on behalf of entire Department of Computer Science, on behalf of the students. I'm sure they have learned a lot, got to know a lot of new things, and you have also aroused another level of curiosity into them. That
Yeah.
is what I'm sure of.
Yeah.
And like every year, I know they must have gained a lot campus placements point of view, because advanced Java, as we all know, is a very important concept.
Yeah. Yeah.
So I would
Streams
if
are
any of the
important.
student,
Yeah.
sorry sir,
I think stream is important concept, and
correct.
yeah, they
Yeah.
should master it. Uh,
Hmm.
yeah, I felt like I should have probably got more time.
Yeah, sir, it happens every
Yeah,
year. I mean,
yeah.
you take it to so much different levels that we are always short of time.
Yeah.
But nevertheless, I believe that students have utilized it to the fullest. And also, all the students, I have shared the feedback form. Please fill the feedback form. Only after that you receive your certificates.
Okay, so thank you everyone. At least, yeah, and thanks to you for giving me this opportunity. Okay. Yeah.
Yeah, and sir, offline also, I would like to know your feedback about the students.
Okay.
Like every year.
Yeah, sure.
Yeah.
Yeah.
Okay.
Yeah, they were actually till yesterday they were quite participative. Today,
Yeah, yesterday
I
they
think,
were.
yeah.
I had seen today. Number is also less, and today I think they are already overloaded with the concepts. I felt
Okay. Yeah.
today very less participation. I saw.
Yeah.
Maybe just my observation. I'm not sure.
Yeah, and that's what I also felt. So.
Yeah.
Yeah.
So yeah, can anyone of you tell that why less participation today? Students, Yash or Rohit? I'm not sure they want to reply. It's okay. Yeah. Anyway, sir, thank you so much.
Okay, thanks everyone,
Yeah.
and
Bye-bye.
best of luck to everyone. Yeah.
Yes, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay, I'll update
Thank you,
the
sir.
yeah, I'll update the repository, and I'll share the this video also. Okay.